We are back. I am your host, Dave, 10-year intellectual property attorney, dealing with everything. As you can see, the shirts, patents, copyrights, trademarks, and trade secrets. And today, I'm getting back to my roots, patent law, IBM. We're going to take a look at the article. We're also going to take a look at the patent they just filed for patent protection on 4D printing. Now, a lot of you guys may not know what 3D printing is, much less 4D printing. So you're in the right spot to learn a lot about these additive manufacturing a lot of times, as opposed to hearing saying 3D printing, particularly in patent law, we'll say additively manufactured, which essentially means the same thing. But essentially, 3D printing is, a printer is kind of building an object, whether it's this bottle or whatever the case may be, this cup is building it from a printer, and it's depositing thin layers of materials on top of each other until you get the final product, whether it's this bottle or the cup here. And essentially, what 4D printing is the same, is building off of 3D printing. So you're printing an object, but now the object is allowed to move based on different things applied to it. So, if you apply heat to it or air to it, it moves in a predetermined pattern. If you apply some type of current to it, it's going to move that 3D printed object into essentially a predetermined pattern. So that's essentially what 4D printing is. You're taking a 3D printed object that's allowed to deform in a predictable way based on some type of influence, whether it's, like I said, heat, air, whether it's a current, some type of influence that causes that 3D printed object to move. So essentially, hopefully you guys got the foundation, because we're going to quickly take a look at the article. Anytime it's dealing with patents, I always like to kind of go through at least claim one, just to show you how to read a claim and provide some value for you guys in that way. Again, some housekeeping items before we kind of get to the article. Number one, please hit the like button for the YouTube algorithm, as well as hit the subscribe button to be a part of the IP community, where we talk a lot about everything intellectual property. We do these current events. We kind of look at patents. I bring up people who have invested in their business, developed a product, protected their IP, and I kind of go through their journey. I also do these Shark Tank pitches. I know today is Friday, so a new Shark Tank episode, I think, is airing today. So we do those Shark Tank pitches. So it's a lot of things that we do on the channel that I'm sure you'll be able to get down with. So definitely please hit that subscribe button to be a part of the community. So let's pull up the article here. And this is fresh off the press. This is a couple days ago. IBM secures patent for 4D printing. Smart Material uses ML is machine learning. I probably would have spelled that out in the title. But Smart Material uses machine learning for transporting microparticles. Let's get to it here. Tech giant IBM secured a patent. I don't think it's an actual patent. I think it's a patent application. I don't think it's issued into a patent. So that's a good distinction to note. From the USPTO on its technology for transporting microparticles using 4D printed smart material. According to the patent application, these smart materials can use shape memory alloys or polymers, which is plastics, that respond to external forces like temperature, light, magnetism, or electrical current. So again, this shape memory alloy is the object that, again, is 3D printed, and it has this kind of shape memory alloy, or it can be a polymer, but it responds to external forces that like I said before, whether or not it's being cooled, it's being heated, you have some electrical current to them. And again, it deforms in a predictable pattern. That's essentially what this whole 4D printed object is. After being deformed, the smart material returned to their original shape, allowing the researchers to induce movement in them and use them to transport minute-sized particles that would be difficult or impossible to transport using traditional delivery methods. So essentially, all this comes down to they're trying to deliver a particular or transport a particle to a target location. And it seems like that's going to be difficult without using these essentially 4D printed objects, essentially a 3D printed object that can deform in a predictable pattern based on some type of induced electrical factor. External factor. And it seems like based on that kind of 4D printed object deforming, it's transporting these very, very, very small particles to a target location. That's essentially what it is that they're this patent application is dealing with. The user must initially set the delivery path and its environmental conditions and note the item size, shape, weight, and composition to be delivered. Once completed, the machine learning algorithm applies the proper stimulus to move the materials. This could be heat or light that causes one part of the other of the 4D material to respond. generating an action that results in an equal but opposite reaction. So essentially, it seems like a big part of, I know they were saying earlier that these particles would be difficult or impossible to transport using traditional delivery methods. And I would imagine that a big part of that is the environmental conditions, especially if you're talking about something that's within a body. Maybe it's something that's on some type of in an industrial setting where the environmental conditions make delivery or transport of that particle pretty difficult. So this is some drawings, flowcharts of the patent application that, again, like I said, we're going to take a look at the lease claim 1 of the patent, just so you guys can understand what it is that IBM is claiming here. Aside from following the user's initial path, IBM's machine learning monitors the 4D printed smart material for any deviations or blockages. It will resolve the situation, allowing the operator to proceed with little human intervention. All external stimuli or external factors are removed when it reaches its destination, allowing the smart material to deliver its payload. Essentially, this paragraph is what it is, according to IBM, the novelty or the newness of this thing. Not only is it delivering, is it deforming this 4D printed object so it can deliver a particle, but if that delivery is kind of thrown off for whatever reason, this machine learning algorithm is able to get that delivery or that transport of the particle back on track by kind of taking into a number of different things into consideration. This paragraph right here is essentially the newness according to the novelty, according to the IBM of the patent. Let's finish off these next few paragraphs. This design allows for the delivery of microparticles between 1 and 100 microns in diameter. So I said very small particles. Furthermore, it's different control methods, mean it can travel through various media, making it useful for medical and industrial applications. For example, doctors and medical technologists could use this technique to deliver drugs to specific cells via the blood or the gastrointestinal tract. It could also be used for miniature electronics manufacturing and perhaps introduce a new semiconductor manufacturing material. So that's pretty much it. Let's kind of pull up the article really quickly to go through it, or not the article, but the patent application. Just kind of really go through the claims. Let me see if I can show the entire screen. Let's go here. Hopefully you guys are getting something out of this. I'd love to hear you guys' comments in the feedback in the comment section. Hopefully you guys can see the screen. So to the left here, these are, essentially the patent application. So I'm not going to go through it, but these are some of the drawings. The big part of this one is the flow charts and figures 3A, 3A, continue, 3B. So these are the flow charts which are extremely important. But we're going to kind of take a look at the claims. This is going to be the most important part from our perspective, as far as what is IBM trying to actually patent. For those of you who don't know, as I kind of try to bring the screen back on myself, you have this patent application, and it includes these figures, it includes a detailed description, it includes an abstract, all these different sections. But the most important section of a patent application is the claim section, because it's determining the scope of the invention, or what's novel or non-obvious about that particular invention. So we're going to take a look at claim 1. Typically, patent applications have 20 claims, at least here in the U.S. Once you start having more than 20 claims, you have to pay, the government additional fees. And out of those 20 claims, you have what is called you're allowed 3 independent claims, which are considered standalone claims. Then you have dependent claims, which depends off of a standalone claim, which you guys could kind of figure out here in a second once I pull up the article. Like I said, we're going to take a look at just claim 1, because that's typically the broadest claim. And whether or not that gets allowed or not during prosecution remains to be seen. But this is essentially what they're saying is new and non-obvious. Let me see if I can kind of blow this thing up. Hopefully that's a little better. Let me see here. There we go. So again, claim 1 is a standalone claim. Let me see how many claims this application has. Yep, it has 20 claims. And out of those 20 claims, it looks like you have at least 1 independent claim, which is claim 1. Let me see if I can find some more independent claims. You have claim 9 is an independent claim, which is, again, a standalone claim. And then I would imagine, okay, it looks like claim 17. Yep, claim 17 is that 3rd independent claim. So 20 claims, 3 independent claims. Let's go to claim 1. I call claim 1 a standalone claim because it doesn't depend from another claim. So you see claim 2 here. It says the computer implemented method of claim 1. So that's the claim 2 depends on claim 1, whereas claim 1 doesn't depend from any other claim. Hence, that's why it's a standalone claim or an independent claim. In this case, a computer implemented method. So it's a method claim. Typically, you can have a system claim, an apparatus claim. You have a number of different claim types. In this case, it's a method claim. So in other words, it's trying to protect the method of something. Let's go through it here really quickly. The method comprising sending one or more instructions to apply an initial and influencing factor to smart materials of a 4D printed object, where the 4D object is configured to deliver one or more microparticles from a start location to a target location along a delivery path in response to the initial influencing factor be applied to the smart materials. So essentially, like I said, that 4D object is a printed material that is allowed to deform and essentially is allowed to deform to deliver that microparticle, that very small particle that I talked about between 1 and 100 microns from a start location to a target location along that delivery path. It seems like they're allowed to send an initial influencing factor. That influencing factor, as we talked about, or at least as the article talked about, can be a current, electrical current. It can be heat. It can be some type of magnetism. This electrical current, this influencing factor is what's deforming that 4D object. Let's go to the second step. Sending one or more instructions to monitor movement of the 4D object along the delivery path in response to applying the initial influencing factor. So essentially, they're applying this initial influencing factor to deform that 4D object and allow that microparticle to move along the delivery path. Then they're monitoring movement of the 4D object along the path. Then the last step, in response to determining that the 4D object has deviated from the delivery path, sending one or more instructions to use one or more machine learning models to dynamically weight the initial influencing factor applied to the smart material. So essentially, they're saying, hey, if this microparticle that's kind of moving along the delivery path based on the 4D object deforming, if that deviates from the delivery path, then we're using these machine learning algorithms, these models, to essentially weight the influencing factor to try to get that microparticle back on the intended delivery path. So that's essentially what claim one is claiming. Whether or not they have to make this more narrow during a prosecution remains to be seen, but that's essentially what it is that IBM is looking to claim in their new patent application surrounding 4D printing. Hopefully you guys got something out of this. Please hit the like button for the YouTube algorithm if you did, as well as hit the subscribe button to be a part of the IP community. Again, leave your comments in the comment section. What do you think about this technology? Do you think it's already out there? Do you think IBM is the first to do it and they're going to do some great things with it? We saw the article. This thing can be used industrial applications, semiconductor chips. It can be used for medical purposes. So it has some applications in the real world. And I would imagine it seems like a lot of people would want to get their hands on it. So I would love to hear you guys' comments in the comment section on what do you think about IBM's new 4D printing technology. Hopefully you guys got something out of this. I'll see you guys next time. Peace.